Good morning again, and welcome to the forum, Our Future of Artificial Intelligence, Opportunities and Risks. As we saw from Giannis, AI is reshaping how we live, work, and connect, or educate, as in Giannis's case. It can open doors, it can widen gaps, and in the words of our good friend ChatGPT, AI is not just the tool we build, it mirrors our ambitions, our values, and our blind spots. Today, we bring together leaders from business, government, and academia to focus on what matters most. We'll look into real impacts, practical safeguards, and opportunities ahead. Our aim is clear: lead with clarity, responsibility, and concrete steps to ensure AI serves the public good. With moderator Deanne Bell, today's panel will explore three themes: AI for social good, AI to advance well-being, AI for governance and ethics, and with Giannis, AI in education. Our panelists are from some of industry's leading companies, universities, and the government, and we are grateful that they are here to lend their time, expertise, and perspective. The panelists include Brian Cunningham, Chief Operating Officer of Foundation LLM AI, Sanjeev Mahindra, Group Leader AI Technology at MIT Lincoln Lab, and Mitchell Schnall is Senior VP, Data and Technology Solutions, University of Pennsylvania Health Systems. Allow me to start by introducing our moderator, Deanne Bell. Deanne is a mechanical engineer, television host, and entrepreneur. She has hosted programs on PBS, ESPN, Discovery Channel, National Geographic, DIY Network, and CNBC's Make Me a Millionaire Inventor. She is the founder and CEO of Future Engineers, an education technology company that engages students through online design challenges. NASA selected Future Engineers to run the Mars 2020 Name the Rover contest. Earlier in her career, she worked at Raytheon as an optomechanical engineer. She will introduce each of our panelists, who will then have 10 minutes to present their topics individually. Full bios of all panelists are in your program and on the NAE Annual Meeting webpage. Afterwards, Dan will open the floor for discussion and Q&A from our audience. I encourage you to engage and ask questions, but please do not pontificate. With that, I've seen it, trust me.
Thank you so much, Al. Thank you. And thank you, everyone, for being here today. And welcome to the 2025 National Academy of Engineering Annual Forum. This year's theme is Our Future with AI, Opportunities and Risks. And there's no doubt that AI has impacted all of our lives, our professions, society as a whole. And the goal of today is really to have a dialogue with some of the greatest minds of our nation about how AI is impacting our world. It's less about algorithms, but more about how AI is intersecting these three subjects that Al just mentioned. We have AI for social good, where Sanjeev is going to be talking about AI for social good, and he's the group leader at AI Technology at MIT Lincoln Laboratory. We also have Mitch Schnall, who's going to be talking about AI to advance our well-being. He's the Senior Vice President of Data and Technology Solutions at Penn Medicine. And we also have Brian Cunningham, who's going to be speaking about AI, governance, and ethics. And he's the Chief Operating Officer at Foundational LM. And of course, on stage, we have Giannis, who you guys all listened to earlier, who spoke about AI and engineering education. And the way the forum is going to work today is our three panelists here are going to give little mini lectures to really entrench you all in the subject matter that they are going to talk about here today. And then after that, we are going to turn it over to all of you for questions and answers. And you can see we have two microphones there. And I expect this to be a lively discussion today because this is a topic that is so pressing to all of us. So we're going to get the dialogue started here. First with Sanjeev. So I'd love to introduce you to Sanjeev Mahindra. He's the group leader at AI Technology at MIT Lincoln Laboratory. And his work at MIT Lincoln Laboratory is advancing artificial intelligence that strengthens national security. His team develops next-generation capabilities in foundation models, scientific discovery, multi-agent systems, and safe and resilient AI with emphasis on real-world operations. Mahendra's research focuses on AI engineering for scalable, mission-ready solutions, including distributed architectures that coordinate across domains and systems that can sense, decide, and act in dynamic environments. He works to ensure robust performance under adversarial conditions and to enable trusted human-machine decision-making. Before joining the laboratory, he helped build smart computing and storage solutions at a startup and provided technology consulting at Arthur D. Little. He holds a PhD from Cornell and a BTech from the Indian Institute of Technology, Delhi. Sanjeev, take it away.
Thank you very much. It's a pleasure to be here, and it's an honor to be here. Like Yanis, I did my undergrad in chemical engineering, so we have that in common. Hopefully, I can learn a lot from Yanis's talk earlier this morning. So, I'm going to be framing some of the discussions today. So we all have 3 slides. Al told us no more than 3 slides, no animations, nothing. So 3 slides. The first slide is going to frame in buckets AI for good. The second slide is going to talk about some of the challenges or some of the things that we have achieved so far. And finally, I'll stop at what future holds for us and kind of lay the grounds for our discussions and have a lively conversation. So maybe raise some sticky issues here and there. So AI for social good. Again, I have 4 buckets as well. Like Yanis, I guess it's in the chemical engineering field to only think in 3s or 4s. The first one is global security, and I think AI holds a promise for improving food, water, and energy security, right? So there's a lot of work that's happening in crop sciences, in agriculture, and in water treatments and so on, which will benefit greatly from AI, as well as energy security. Of course, AI and energy is tightly linked. AI consumes energy, and AI could also hopefully help energy as well. Given this plentiful AI, hopefully this will lead to global stability. Certainly, AI is being used for national security by all countries, and that's something we do a lot at MIT Lincoln Laboratory. And AI is also starting to be used for public safety, law enforcement, and things like that as well. On a global scale, AI is right there in terms of modeling climate change, modeling environments, modeling weather, and so on. Google is doing quite a bit of work on that. And also in being able to deal with situations when you have adverse events, floods and hurricanes and things like that, to be able to get the relief to the right place at the right time. Switching gears, scientific discovery. Yanis talked about this earlier today. There is a lot of data that needs to be exploited and can be exploited to augment the human in terms of being able to provide new scientific discoveries. There's a lot of work going on in this field. Some universities and some companies are also starting to build automated experimentation labs, the so-called self-driving labs, where you have not only AI screening materials for building, but also then closing the loop, actually building materials, and then trying to learn from that data as well. And in terms of design innovation, there's tons of opportunities in designing molecules, materials, drugs, as well as engineering solutions. I think there's a huge amount of opportunity in both science and engineering with AI. Healthcare, there's opportunities in acute care and diagnostics. I think Mitch is going to talk about some of that. There is opportunities in AI for chronic disease management, as well as senior care and aging support. So robotics might be able to help our seniors and people provide support at home, as well as wellness and mental health apps and wearables and things like that, and we can get into how well the current state of AI technology is to support these things. And finally, Giannis, did an outstanding job of, talking about education. I just want to add, he had an equation which had S1, 2, 3. I want to increase that S1, 2, 3 to infinity. So, the professors can actually influence and deal with students at scale. So I think that's going to be another opportunity that AI provides to the star professors. Next slide, please. So here are some examples, and I briefly, go over some of those. And I think you've seen all of these. DeepMind with AlphaFold protein structure predictions is, and there's a lot of work going on in that area. AI for precision agriculture. John Deere is working on some crop technologies, putting it right in the field with tractors and things like that. You can use computer vision to look at, the crops and decide where and what kind of a nutrient needs to be provided, what needs to be watered. My personal favorite, materials and energy discovery. We have a lot of work in our group in this area. We are building, looking at the inverse problem. So typically, we have, what we do is look at materials and try and measure their properties. What we want to do with AI is the reverse problem, the inverse problem, which is given a certain property, what material will fit those properties, and there's work going on in that area. Patient care robotics, I think this is early in the process because robotics is not as mature yet, but there is a lot of opportunities that we have. A lot of companies are building the humanoid robotics. This is a company in Japan that's building Robert, which is humanoid, but it's more friendly humanoid, I guess. Opportunities for weather prediction. Google is doing a lot of work in that. We are doing some weather prediction work as well. We are also building sensors to be able to measure, the kinds of damage that we have and plan the best routes to get the relief to people who are affected. And of course, the other opportunity in terms of education that we have is personalized teaching, as well as making it globally available. So I think these are all some of the things that are happening now. Still early in all of these stages, but this is just laying out some of the things that we have. And next slide. So I think this should get some good discussion going. So we have, it's the best of times, it's the worst of times kind of thing with AI. So one future is the age of abundance. We have AI, which is, everywhere, which is providing, democratized access to all kinds of services. You have your own doctor, you have your own nurse, you have your own teacher, and the cost of providing those services is essentially the cost of compute and the cost of energy, right, at the margin, right? So I think that's a huge thing that'll provide abundance, and so then there's implications for that for human, what will the humans do? There is accelerating breakthroughs in climate, health, food, and energy security, like I talked about, and then there is the challenges that we have on the other side is, if we don't have a diffusion of this technology, we might have islands of plenty, but we might have, lot of scarcity across AI, across the world in terms of who has access to AI. And so AI will make things unequal, and you'll see a lot of strife because of that. There's environmental risk. AI, currently is burning a lot of energy, and we are seeing that, in the U.S. in terms of building power plants and things like that. And we are currently not very well suited, at least in this country, to be able to support the large-scale deployments of AI. The unemployment picture, I think that's another thing we need to be thinking about. I think there's some people who say there's going to be more jobs that are created, and that might well be true, but I think we need to plan for multiple kinds of futures and think along those lines. And then weaponization of AI, right? I think Brian is going to scare you some more, but I'll scare you a little bit. So For autonomous weapons, for cyber warfare, for disinformation, I think there's, opportunities to use AI for good and for bad, and I think we are seeing both happen. And then, of course, there's the existential risk. AI becomes, super smart and decides to take over the world and cause an existential crisis for humanity. So I'll stop there, but
That's a great place to stop.
That's a good place to stop, I guess, right? Brian is going to scare you even more. So
I have no doubt there'll be lots of questions.
So thank you for your attention.
These tales of two futures. Thank you, Sanjeev. So now we're going to transition to Mitch Schnall. Mitch Schnall leads Penn Medicine's enterprise data and technology portfolio, overseeing the offices of the Chief Information Officer, Chief Medical Information Officer, and Chief Analytics Officer. In this role, he advances IT-enabled process automation, care redesign, and analytics to improve clinical and business outcomes across the health system. An internationally recognized leader in translational biomedical imaging, Schnall's research has shaped modern approaches to breast and prostate cancer imaging. At Penn's Perelman School of Medicine, he served as chair of radiology, where he doubled the department's size and research funding, unified academic programs across Philadelphia hospitals, launched a single top-ranked residency, and built a collaborative framework for One Penn Medicine Radiology that connected community practices with academic missions. He's a member of the American Society of Clinical Investigation, the Association of American Physicians, and the National Academy of Medicine. Schnall earned his MD and PhD at Penn, where he also completed his radiology residency. Welcome, Mitch. Thanks for sharing your thoughts.
Thank you. And so I've also put just a couple of slides together. Really struggled trying to figure out in 3 slides how to talk about the potential impact that AI could have in medicine. I do have one slide that I often show when I'm asked, where is AI going to influence healthcare? And it has one big word on it diagonally across the slide. It says everywhere. But I've tried to frame a couple of, I think, important concepts in terms of how AI might influence medicine. Next slide. This is actually the perfect time to be thinking of AI in medicine. If we look over the last couple of decades, there's been an explosion of, I'll call it, diagnostic measurement technology. We're measuring more and more about people's health. We're able to do it more and more quantitatively. And we've also started to develop an EHR that we're starting to put this information in. And so we're accumulating data on patients over time. We have better tools to be able to interpret this data, particularly one of the challenges we face is a lot of this data is taken either unstructured or in different standards. So we have tools now that are better at interpreting across those standards. And we have better technology at trying to merge data from across enterprises, both with the ability to do federated learning so we don't have to actually take data from enterprises and other things to protect privacy. And so that really starts to allow us to train systems in ways that we may not have been able to thought possible before. And really changes the concept of medicine almost from a primarily biology-driven enterprise to a data science-driven enterprise. And so when I was in medical school, I was taught the art of diagnosis. And it was, I call it a scientifically informed art. You put a label on a patient. A patient could be a diabetic, maybe a type 1 diabetic when we got a little bit smarter about diabetes. But imagine going forward that a patient's diagnosis is a point on a multidimensional space that is defined by axes of all the different measurements that we may make on a patient. And we develop models that really try to predict how a patient is going to walk in time around that space. Then we can start to ask questions about the levers of how to change that trajectory. That gives us great insight into how to treat an individual patient or potentially opportunities to treat classes of patients and develop therapeutic strategies. So this can fundamentally change how we're making decisions about patients. It can fundamentally change how we think about identifying therapeutic targets for classes of patients, and really change the way we think of medicine, as I said, from really a primarily biologically driven science to really a biologically informed data science going forward. Kind of the next slide. I also want to talk a little bit about framing the patient-provider experience, this sort of pragmatic part of medicine that we all see, and I live this every day. Over the last 20 years, we've seen the rise of the electronic health record. A lot positive in the electronic health record, but I think the electronic health record had a couple of jobs that it needed to do. It was our repository of data, and it performed a lot of transactions. We order medication, it transacts that order. We send out bills, it transacts that order. So it does a lot of transactions for us. Those transactions required structure. We have to get them accurate. It also was the primary interface that providers and patients interfaced with in order to put that information in and get information out of EHR. That's not interfacing to a particularly structured environment. And so because of that, we had to have an entire enterprise to try to really bridge from the unstructured environment to the structured environment. We all walked into doctors' offices these days and see the doctor with their head in their computer. There's some great cartoons about that. So that it really affected the patient-provider experience to the extent that I can tell you I still practice medicine as a provider. One of your goal is almost as much as satisfying the EHR than trying to satisfy the patient. And making sure you're satisfying all the EHR's requirements. Well, one of the things we're starting to see with the advanced Gen AI tools is the ability to develop applications that bridge that divide for you. And one that I'll point to that really we may have all seen is the ambient documentation, where instead of the physician with the head in the computer, they're just putting out a cell phone, having a conversation, and it grabs all the documentation, fills out the notes, and does a lot of things for the physician. And so it rekindles that old physician-patient experience where you're just having a conversation with your doctor, and your doctor can concentrate on that. There's a number of other things that these applications do. They deliver information, because they also can get information from textbooks, from the whole archive of medical information, and bring it to the point of care when you need it. There's potential democratizing of medical information there. It allows, frankly, less trained, less qualified practitioners to get access to more sophisticated data, more sophisticated information, co-pilots to help them. Potentially very important as we are getting more and more access challenges to provide more and more access to more sophisticated care to more people. Now the next slide. So there's a lot of challenges that we have to navigate, and I'm just going to talk about just what I'll call the top three. The first is I don't think we have a good framework for what the human-machine collaboration looks like in medicine. There's a lot of discussion about a human in the loop. What does that mean? Does that mean the human has to be in the loop for every single decision an AI system makes? Or does that mean a human has to be responsible for overseeing an AI system and it's performing appropriately within the confines of what it's being asked to do? I don't think there's a framework for how we think about quality control. How do we think about what the standards are and how we ensure that we're complying with those standards, what the responsibilities of the healthcare provider are, what the responsibilities of vendors that provide these systems are, how we work together to ensure we're delivering the best high-quality medicine that we can deliver. And I think we need an approach to that. And then still, although I showed a great vision of what we can do when we train on a lot of medical data, how we aggregate data so that we can actually train models this way and be able to satisfy some of that ambition is still a challenge with both some technical challenges, but just as much policy and organizational challenges that prevent some of the data from being aggregated easily and trained. And so I look forward to further discussion.
Wonderful thoughts, wonderful thoughts. All right, so we've heard about AI for social good, AI for advancing our well-being, and next we're going to hear about AI governance and ethics. And Brian Cunningham is going to be speaking to you all about this. So Brian Cunningham is the Chief Operating Officer at Foundational LM, where he guides strategy, operations, and partnerships at the intersection of national security and advanced computing. He brings more than 25 years of service as a Navy SEAL and Senior Special Operations Officer, leading high-stakes missions and innovation initiatives. In industry, he's served as a Director of Strategy and Growth at Soliance and as a consultant to defense technology firms on artificial intelligence and machine learning. His work in data analytics at Naval Special Warfare and AI integration at U.S. Special Operations Command, advanced human-machine teaming for mission performance, and enterprise decision-making. Brian advises multiple defense technology boards and is a board director for My 360 Tribe, a nonprofit that supports veterans in transition. His expertise includes foreign ownership, control, influence oversight, international security policy, and applied AI. He holds degrees from Villanova and Princeton, with additional graduate study at Stanford, MIT, Dartmouth, and the University of Texas. Welcome, Brian. Thanks for sharing your thoughts.
Thank you. Thank you for having me. I appreciate it. I think Sanjeev kind of teed it up that I'm going to be the Darth Vader in the conversation, and I can promise you I won't. It'll be a little bit more of a Bruce Willis where we get to the happy point at the end. But I am kind of the outlier here in that in the National Academy of Engineering, I'm not the engineer, but the key topics that I want to talk to today are essential in terms of governance and AI and how we look at it, the ethics that has to be brought in. Yannis discussed, how we need to teach this at a fundamental level. And so I wanted to talk a little bit to those points up front, the potential and grounding in the fundamentals, right? So we always say in the SEAL teams, you got to be brilliant on the basics before you can do the most advanced things. So next slide, please. So up front, some key grounding, is AI, we talked about processes data, but it doesn't just process data, it actually shapes the reality that leaders look at and believe. How do I know this? So I'm a neophyte to AI in that 2018, I was a task force commander in Iraq and Syria, and I was what we called a TIA, a Tactical Engagement Authority, which means that I held ultimate responsibility and accountability on deciding operations. So whether or not I send 20 special operators into the night sky, after a senior terrorist target, or launch a missile and own the ramifications of that, at that time, about 20 to 25% of the information that I had to make that decision was coming from AI. Back then, we had a program called Maven, which was a computer vision-based technology that was being integrated into, special operations. And so while I had all these different, pieces of information, in true special operations form, it's, if you're going to learn, you might as well learn it from the fire hose, so take a sip out of this one. Go figure it out, and oh, by the way, here's the unbelievably high-risk outcomes that could potentially happen as you make your decision. This translates pretty well now as I see, from my civilian seats and in the community of AI adoption across government, academia, as well as corporate and commercial finance, all these different places. So, you see that there could be a potential issue with the information that you make a decision as a leader on. So what's our guardrails and how do we look at this? What does that translate to? Healthcare, as we talk about radiology or imagery, computer vision, some of the first computer vision-based capabilities, we're looking exactly at that. There is a potential for bias of information that AI processes and could create, potential differentiation and urgency of the diagnosis. You look at finances and financial aspects, information and data that's shaped into that could potentially create a bias that now influences an entire financial institution and how they approve loans or how they grant credit, how they look at, population sets based on this bias. Sports, a great one of our customers that we worked with in sports, you look at for utilizing AI for predictive athlete performance, potential injury diagnosis and prevention. And now all of a sudden you have a coach or somebody making a decision on an athlete that may have, prevented them from performing at that level that they should have, preventing some of the fan bases that come because their favorite player is benched based on a bias of information that may have, injected into the decision-making cycle. Key things, infrastructure. A great example was in the European Union, and they started using AI to help with management of power load capacities, and based on a differentiation of information and perception, the AI started shutting down, major power grids because it had false inputs and caused a decision-making cycle that was biased and wasn't based on truth and wasn't based on the current data. Next slide, please. So governance and architecture. I look at this, we talked about the human in the loop aspect, so hopefully the HITL kind of, translates to everyone at a fundamental, basis of it. We look at it in my experience of trying to do it in a layered fashion on how we need to help with this governance and to maintain an ethical guardrailing, as we utilize AI to augment humans, to be a co-pilot, is a lot of the common terminology that you see. But it's got to create in a kind of a layering fashion to be successful. So when you look at it, the first layer in my mind, and probably resonates with everyone in the room, is the technical layer. So at the fundamental design layer of where we bring the governance and the guardrailing and the oversight of human touch points and human accountability to the technology is in the technology layer. So we have these large language models. I showed that they tend to be more opaque. Our role and our technology focus needs to be making them more clear or even transparent on a pathway to a clear box versus a black box. We do that through, model lineage, our ability to actually create audit trails and understand. The company that I work at right now, one of the biggest pieces that we have is the ability of whatever the output is from the AI or the generative large language model to quickly click and figure out exactly what was said, what was the prompts, how was the thought cycle for which the AI got to that outcome and produced, that answer. Accountability needs to be the first piece that's built into each of these capabilities. Next is, being able to present that in an explainable fashion. So as I would stand in an operations center and, trying to make a decision, I wanted to see all of the different information presented in a fashion that I could digest it, quickly and to a level that would help me make the most informed decision as possible. Because, reality is we all want to have exhaustive research that provides us, irrefutable data to an outcome. But the reality in life, even with AI too, is there's going to be some gap of information. And so you have imperfect information that you still have to make a decision based on. Other pieces, when we talk about model cards and documentation, this comes down to kind of the basic tenet and premise, of you can't really audit something that you don't have instrumented, right? So you have to have some sort of metrics and dial-ins to be able to show, hey, what is this? Where does the bias eke in? Where can it be touched? The next layer in my mind is then the procedural layer. So, working my way through, God knows the military, but in organizations and especially as an operating officer, I got to have my process. We've got to have processes in place to be able to account for any of the pieces that work in between. And so procedural layer, we're all familiar with it, institutionalizing them. Red teaming is one of the greatest pieces, smoke testing, having somebody that does nothing but try to actually poke holes and find leaks and find that needs to be kind of a key piece. A tiered methodology for actually evaluating and putting things in the bins of, hey, this process, this automation, this AI functionality is really low risk. If it makes a bad decision, then it just really disrupts whatever, Brian's calendar for the day, or take it all the way to the high risk of, hey, if we automate this and there's no human in the loop on this aspect, this could potentially lead to a misdiagnosis and the death of our patient. That's pretty significant. Create your tiered system and bring these things into scope so everyone has a grounding of risk to reward. The third layer in my mind is then the overarching, going from tactical all the way to strategic, is the institutional layer, and that's governance. A lot of the organizations, probably most of your universities and most of your organizations that you work with, have these kind of committees, whether it's an AI ethics committee, something that at some periodicity takes a broad spectrum review of everything we're doing and asks those hard questions. Hey, are we doing this right? Is this the right reason that we're doing this? Let's have some of that oversight. Some of the financial institutions that we work with, they create risk councils. Banking is all about risk, right? So they have councils that adapt and say, hey, should we adopt this automation in this? Is the risk versus the reward worth it? And have that oversight. So an institutional layer that provides kind of that overarching piece. Because at the end of the day, this isn't just about risk avoidance. Done right, governance ensures that AI elevates human decision-making and not erode, the leadership requirements that have to happen in a human level. Next slide. Okay, so coming up here, positive, right? Here we're getting positive, but with some hard questions, to kind of propose back into the crowd. So when we look at our overarching tenet of leadership, it's oversight and acceleration is attention when we look at the engineering aspect of it. That is the speed at which we need to move. So when we look at mechanical speed versus moral speed, this is where we inject, our leadership, requirements and tension. So when I talk to a room full of computer scientists or data scientists or technicians, I get a lot of furrowed brows and eye rolls about human in the loop aspect because that slows it down, that creates another step and a level. I talked about the frameworks to try and maintain human in the loop responsibility and accountability at the same exact time of being able to move at the speed of innovation and within a reason, but we have to judge that piece. And so frameworks to help guide that and to grow that. The same exact tenet that I push back, with some of those engineers on is the aspect of, okay, well, if we can move the technology at this speed and acceleration, why can we not move, our ethical governance, capabilities at that same speed? And we need to, because that's the way we maintain pace, that's the way we maintain balance in this tension, because the outcomes, as you can see, are pretty significant in terms of what happens if we do nothing. We do have that ability. We're showing it right now. Companies are running into this space, making the different types of data, clean data, dirty data, completely irrelevant so we can get it in there. There are companies that are focusing wholly on developing large language models that are clear, that are a transparent box that people can see and understand and learn from that. We're moving at that pace of innovation. The ethical pieces that we need to incorporate into that have to move at pace, and we have the ability to do so. It's more about the leadership at all those levels to ensure that we maintain that and hold on to the key tenet at the end of the day, which is in order for AI to be effective in advancing humanity, humanity has to hold on to the leadership of that technology advancement. Thank you very much.
Thank you for all those words. And I know the questions are brewing in everyone's heads. So at this point, we're going to transition to our Q&A. So we have these two microphones here. So go ahead and start queuing up to ask all of your questions. I'm going to kick things off with, I guess, digging a little bit more about, I know we talked about the framework for the human-machine interaction. We've talked about human in the loop. I think all of you mentioned human in the loop, even on the education side. I guess I want to hear from each of you about whether this human-in-the-loop need is something we think is pressing now or forever. Do we think that this technology is going to advance to a point that we can set things free, or is there always going to be this level of accountability, liability, that we're always going to have that human-in-the-loop necessity?
Well, I can comment on this. And I actually think that, again, we have to define what we mean by human in the loop, right? One, imagines this means that every time an AI system does something, the human's right there to look at it, and it just informs the human and doesn't actually automate anything. The challenge with that, and I'll speak to medicine, where we're in a situation where the need for medical services is continuing to eclipse the resources we have to provide it. We're already seeing the inability to provide access. That type of human in the loop actually slows us down, doesn't accelerate us, and actually may improve care for those that can get it, but actually denies care to a lot of people. right, and isn't necessarily the right approach for health. I look at human in the loop in terms of having accountability for the system, ensuring that the system is operating, ensuring that it's meeting its standards, and ensuring that it's providing safe and reliable care. Look, systems are going to make mistakes. Humans make mistakes, right? The challenge is, how do we ensure that the systems are operating at least where human performance would be in delivering the services that we need to deliver?
Yanis.
The way I look at it is essentially the ultimate authentication of AI. And you need people that have, I mentioned this deep domain knowledge, to be able to understand intuitively, in a different way, what actually the AI will predict for you. In this sense, because it augments your intelligence, but at the same time, you have to have a measure by which you can measure that actually what it is predicted is actually valid, useful, and harmless, as I mentioned before. I think that's why I believe that our students need to have a very deep understanding of their field and not simply outsource this to an AI that can do that. Because if you don't have that, now AI can give you new innovation potentially, and that is something that you can also judge based on the ability that you have that, and then retrain yourself to some extent. So there is a symbiosis in some sense. So when I talk about human in the loop, I mean it in that way, that you have sort of an authority that can actually tell you that. Now, if the future goes in a direction that humans become obsolete, then then we go into a different direction altogether.
Okay, I think we're going to have some questions from the audience. We'll start over here. Yes.
So my question is actually a follow-up to the topic that Deanne started about human in the loop. I heard a discussion last spring by a bunch of clinicians, medical clinicians, and they're very worried about de-skilling, and the notion being that the best clinicians are really good at diagnosis, partly because of their knowledge and partly because of their intuition and their experience, and they're very good at finding unobvious diagnoses. And they were worried that their community is going to lose is already losing that skill because of AI assistance. We're also starting to see that in computer programming, that the marketplace is hiring a lot fewer introductory coders that we've been training for years because they're generating code using AI tools. And it turns out, there's been one study, at least so far, that if you don't know what the code should be, you can't even assess whether the automatically generated code is correct or not, or functional or not. So while this conversation is starting out in medicine, it's starting to apply to a lot of engineering fields in which we're building these assistants and saying, yes, we'll have humans in the loop. If the humans don't have the skills, as Yanis just said, they can't oversee the process, and yet all the pressures are to de-emphasize learning those skills in our engineering communities.
So I think the question here is about how do we maintain a high level of skill? How do we maintain a high level of critical thinking, kind of symbiotically with the advancement of AI? Who wants to take that? We'll go on the education side first.
I can say something from the education component. So in education, there is a 4-letter word called ABET. ABET is the accreditation agency that comes in and accredits your program. Maybe the ABET has to demand that our students understand these fundamentals, whether there is vibe coding or other things. And actually, I talked to my computer scientist colleagues, and they will agree to that. That there is a lot of vibe coding, but people need to understand exactly what it means, and also how one could create something without having this ability to do this automatically. Because the more complex, more sophisticated coding, in essence, builds on that, and then you have to understand the mechanics of that. What I'm trying to say is that education has the ability to self-audit and also self-govern in that respect. And it's a matter of the professional societies, IEEE, others, who theoretically, support or guide ABET to actually provide this as a requirement. Now, it is true that many universities don't particularly care about ABET, but many do. And so I think that's something that we can do.
And I mean, I can only imagine there's a ton of research going on right now about, in an educational atmosphere, how much you need to restrict AI. Whether in the classroom you're always with AI as you're in your learning experience, or whether you need to restrict it to develop those critical skills. Is that something that you talk about a lot in how to kind of implement?
I believe that right now the landscape is very wide. Many universities let the faculty make decisions on how they want their teaching and to be informed by AI. At some point, maybe there will be some standards on that. I think right now we're in the process of developing this. There are also alternative educational entities that actually have different ways by which they're thinking. It's not amorphous, but it's a domain that is moved very fast, and it is happening right now. You will see a lot of that. I think efficacy, efficiency, the ability to create something fast, sometimes it's actually what drives some of this. There will be, back in 2011, I remember there was this MOOC mania. MOOCs were the thing to do. If you don't do MOOCs, you're nothing. That didn't really work very well in many ways. AI is a very different thing, because MOOCs were throwing information at you, and that was the end of that, more or less. AI is very, very different in that respect.
Well, add a little bit to that. So I think one of the things we have to do to the users of AI is to also train the students to be managers of these AI. So not just, we all love building things and tinkering with technology and so on, but I think the other aspect, the more critical thinking aspect, needs to be inculcated in students at the very early stage. So they are building, but they're also managing these AI, which are also helping them build, right? So I think that dynamic interplay will be key to kind of managing this. So that you're building more critical thinking in terms of what is being given to you by AI, as opposed to, so it's not so much losing the skills, but maybe thinking at a higher level on some of the things. So,
offer something to consider too is, more as a warning than really just an answer of, hey, this is how we fix it. But there is a tension. And for most universities that have partnerships with, actual corporations in America, you're going to have a push for reducing cost and increasing revenue. And sometimes that becomes a hard challenge, to actually create, and I agree, there's regulatory audit oversight that has to tell, a corporation to stop. We have that in law and, legal aspects where we have precedent of, lawyers utilizing, a large language model to help present a case, and it totally, hallucinated all of the key data that came found, and they were disbarred, right? So there's this regulatory component, but the push, there's going to be a lot of pressure to try and change that, because are you cutting costs and are you increasing revenue? And if not, how do we do that? That becomes a hard tension where, regulatory academia has to, come and be able to stand the ground on it too. There's also the other component, and I think it was Peter Thiel who was talking about it, but is, hey, as we start doing some of these things in medicine where we give back time to, to the physician, where he just puts the cell phone on the table, or she, and just lets it happen and not have to worry about the notes and all that stuff. What do we do with that extra time that we just created for that human? The business aspect and the hospital administrator aspect is like, well, give her more patients. when in reality it needs to be, hey, AI is looking to try and improve humanity at large. What do we do with that surplus? How do we improve humanity? Is it, giving time back to that doctor? Is it saying, hey, you now have a requirement to do research? Whatever it may be, we do have to have some of that in our mindset and our heads-up display as these things start happening, to be prepared to make the best advantage of that.
I love that. I love that. What do we do with that surplus to advance humanity as a whole? It goes in line with the age of abundance. I'm on that side. Okay, we're going to take this question.
Excuse me while I bring human in the loop to get this at the right level. So you all touched upon the vast amount of data that's required to train the AI models. And in academia, we have a history of single investigators hoarding that data, particularly when there are opportunities to monetize the research. In the corporate world, same thing, the data can be your corporate edge. So I'm curious your thoughts on strategies for facilitating, convincing, incentivizing the broadest access to data from all the different fields. Thank you.
Mitch, I think that's good one for you.
Yeah, this is a complicated question that we wrestle with every day. And I think there's a couple of things. One is, I do think that certainly in medicine, there's starting to be a recognition of teams can do more than individuals, and a recognition of being a critical member of a team, bringing a critical aspect to what that team does, and helping to move it forward is a very important measure of academic output and impact. And so we've really tried to get away from that individual contributor model. It's cultural, it's deep, it takes a lot of work to do, but I think we've, with frankly some political courage of our leadership have done some of that. But I also, from what you said, point out, the I'll call it the sort of business aspect of that, right? Which is, we as a health system, serve a large patient population. We have a lot of data. What do we do with that data? And from our perspective, we look at ourselves as the stewards of that data for our patients, and that we can't allow that data to do to be used in any way or do anything with that data that we don't think that we can defend to our patient population, and that would not be in their interest. And that sort of is the sort of guiding principle of how we work. So, as an example, we'll never provide data to an enterprise that we don't have control for every use that it's going to be used for, which creates tension, between some investigators and what they want to do, and some of the collaborators that come from industry and what their interest is, wanting data for whatever other use they deem beyond the project they have. So I think this is a set of moving targets, and we're going to probably be having this conversation for years to come.
Yeah, and just to kind of add to that a little bit from the business aspect and from the technology aspect, that's happening, and a good majority of the institutions and companies that we deal with all have that same exact number one premise. This is my proprietary data that gives me advantage. No, I'm not uploading it to ChatGPT. So how do we do that? And so it's already been a forcing function that's happened over the past several years, believe it or not, starting with national security aspects. In 2018, all of that information was on classified networks, right? So now we're at a point in, technology corridors and hubs where the plane is in flight and we are building faster engines while it's in flight in order to be there to protect the proprietary data. Whether that's from external aspects, but also internal aspects too, like role-based access controlling methods that, prevent or be able to allow institutions to say, can't go into the USC ChatGPT portal and ask what the dean of the university's compensation package is, as a student. Some of these things that you can protect internally, you're going to have that governance issue that comes into play. That's ongoing, and it's happening as we speak at varying levels. I think, my opinion, though, is we're going to have to start going from a jog to a dead-on sprint as soon as we hit, this quantum computing cross, because there is only a few organizations and companies that are thickening the quantum computing and quantum encryption, post-quantum encryption kind of environment. And that's something that we have to, is coming faster than we think and is going to be a pretty significant game changer in terms of proprietary data, data protection, and data risk.
Yes, Yanis.
Yes, there is a Form 9099 where the dean's salary is actually put in there. Let me preface that it's not accurate, but that's a different story. Talking about data centers, for example, we had the possibility of creating a data center at our institution, but in order to do this, because the cost is quite expensive, in addition to the energy that you require, that actually is double what the university right now is using, or maybe triple, then you have to understand what are the needs of the faculty in terms of this. So right now we're doing an assessment of that to see whether it's worth the investment and possible partnership with places like NVIDIA and others to be able to do that. Conversely, you can actually find out and go on the cloud and be able to then use cloud resources for that. This actually is happening with quantum because many quantum centers, many universities actually use, let's say, IBM Cloud for quantum and all that. So this commonality exists, and I think many of the solutions will be addressed this way. Most likely a cloud service rather than a bona fide data center in an institution that is not very large. I think that may be the case. Many universities have been working on creating partnerships at the regional level, let's say Los Angeles or Boston or so on and so forth, in which they share resources based on that. So this is happening, and that's something that is,
Questions? We'll go over here for our next question.
Thank you. Thank you for your interesting opening comments. One of the attractions of using AI is increasing the speed of operation, and it's very attractive. If you integrate AI into very complex systems, you will perforce integrate it at many levels of functionality. And my question is about governance. If you do that, and the AI at decisions being made at very low levels, in fact, foreclose options, or exhibit bias, or make mistakes, then what governance options do we have, especially during rapid operation in finance, in medicine, in special operations? Brian mentioned override authority, but that's at the final level. The human is only at the loop at very high levels. He or she is not necessarily interacting with the AI components down at the bottom that are systematically restricting anything approaching to maximizing the effectiveness of the system.
Right.
How do we govern AI, especially in real time operationally, when the AI problems really come from low-level AI components that the top-level operator may not even be aware of?
It's a great question. I think this question is governance, but also quality control, which is something that we've talked about before, right? And how do we collectively as an engineering community ensure that the quality of all these subparts that are leading to the whole, right? So I don't know who wants to take that first. Who's interested in talking about kind of the quality and governance?
I mean, I think there needs to be a framework for quality control, for auditing, to ensure that you're controlling for accuracy, bias, and all the above. One of the challenges is, you can audit what happened, but I think you also, I think, are going to have to set up some simulation systems with simulated data that you run in that have to run within certain constructs. I'll use as an example of what something in a system, that is real. Imaging companies in my world, in radiology, have been going to use AI systems to help in reconstructing images from raw data so that they could reduce the amount of raw data and make the images look like higher quality images. That doesn't mean they have more information in them, right? And it's really clear that sometimes you have images that look really good that miss information, right? They miss a tiny lesion or something because a little speck of high signal looks like noise. And they're trained to find noise and find signal and get the noise out in a nonlinear way. And being able to, again, audit, find those cases, ensure that you're using the systems appropriately, I think are really important. And I think quality control is really central to everything that you've commented on.
I would add too that this is not necessarily a new problem, right? So I mean, as a commander in the military, I had to own the outcome no matter what. And so if I had, a intelligence analyst that was 2 weeks on the job and misinterpreted some information, presented it incorrectly at a level where I had to make a decision, and then that decision went sideways, then I still had to own that problem. This is a kind of a time-tested thing. What I proposed kind of, and is not necessarily a solution, realistically, you have to create two things. And two things in my mind, which I'd have to do is, evaluate and classify some of those automations, those workflows. If it's agents and you have agents doing autonomous things, classify them in terms of risk. Hey, these are low-risk things. This agent is making decisions to whether or not, this page should have a number on the bottom of it or not. Whatever that may be, all the way to high risk. And then gradiate your human-in-the-loop aspect to match those pieces. The other piece that I talked about, that framework of kind of like the triangle, not the pyramid, was integrating at a technology level, have it constructed with the code, with the piece, have your governing and oversight that happens at a higher periodicity that tests and challenges those theories, those processes, those outcomes. And then at a much higher level of doing the large strategic look across a committee and to make some of those decisions, is kind of an escalating kind of proposal to it. Your question is perfect in that has to happen fast, right? So the speed at which that we look at this, we have to move faster to be able to adapt to that. And so I always have found that throughout the military career and special operations, we were forced to move at the speed of trust. And then sometimes we had to move faster than that because the environment, the enemy, was moving faster. And we had to start sprinting. And that's where we are, I think, in my opinion, we got to start moving faster with it.
Yeah, so I think that's a fascinating question about how do you make decisions in a hierarchical organization and still get the right answer at the top, right? So I think from a technology point of view, it might make sense for us to build AI which has the option, or maybe multiple AIs, which give you different kinds of answers, not just one answer, but multiple answers and multiple options with some risk associated and the confidence in each of those answers. And then I think we have a better way of probably integrating things at the very top to be able to make decisions from an AI executive point of view as well as the human AI executive function as well. So I think that might be a way of answering your question in terms of what can we do to build AI which allows us to do that at the very top.
Love that intentionality with humans. Here we go, right here, question.
Thank you. First of all, I'd like to extend my applause to all of you for this wonderful perspective you provided on AI today. It's really very helpful. And I would be remiss as editor-in-chief of The Bridge if I didn't point out that the winter issue of The Bridge this year was focused on AI. Marilyn Croak and William Isaac from Google edited The Bridge, co-edited as guest editors. And it provides, I think, if this audience looked at The Bridge and your commentary today, you'd have a very wonderful perspective. So my loud applause. But I have a comment. I think the introduction of any new technology into our social fabric is a double-edged sword. It all depends on how you use it. I have a sports car that I love to drive fast. but I know there are speed limits. I know the National Highway Transportation Board would not approve if I got into an accident. But then I look at our information age. I look at the introduction of the internet and then the web and now AI, and I don't see the same sort of guardrails. You know, Vladimir Putin is using what he calls political technology. It's the internet. It's all of the things we're talking about today. And yet we have no way of controlling that, do we? There are, on the web, you'll find a great deal of misinformation. Some of the world's most formidable liars have an opportunity to spread whatever misinformation they wish. And there are no guardrails. I just wonder, are we...
Question is about guardrails?
Sorry?
Is your question about guardrails?
I'm sorry.
Is your question about guardrails?
Yes, I am. That's the final question I'm coming to. Why do we not have guardrails? Why are we allowing this new technology to evolve without any of the sort of standards or regulation that have been typical of other technologies when they've entered our social fabric?
Great. Okay, so question about guardrails. And I think this dovetails into, we're talking about almost every company has a committee on AI policy, and things are moving fast, like crazy right now. And I think some sectors can move fast, some sectors can move slow, right? So I guess let's talk about guardrails, and collectively, I think, who's in the hot seat to be creating these on these small levels, local levels, national levels? Yes, so Yanis, I know you want to talk about this. But.
2 points here. I know that some time ago, Eric Schmidt proposed the creation of the equivalent of IPCC for AI, the same sort of thing that happened for climate. Now, of course, climate has fallen off the radar, but in some sense, there has been a proposal of this type. There is a very interesting journal that comes out from the Berggruen Institute, which I recommend very, very much. It's called NOIMA. And this Saturday's article talks about the difference in terms of how AI is approached in Europe versus in China and the United States, and talks about the issue between acceleration and precaution. It's very, so there's very strong debate that's going on, including in Europe right now, on whether Europe is going to fall behind and become what they call a digital colony of some sort, based on this. So these are very significant issues that, because of the fact that AI is such a great and important technology for that. Sure. And also happens at a much, much faster pace than other technologies in the past. I mean, with the internet, we had the ability to adapt over maybe a decade or more. AI is not going as fast. Now, I think this is a political decision, and and you know, we can see how these politics are influenced today differently than before, and so I think that's to me that's a political issue right now.
Other thoughts, Sanjeev? Yes.
Yeah, so I'll address specifically the misinformation, disinformation aspect. I think that's a very difficult thing. I don't have any answers to that, but that's a very important question, and it's very hard in a democracy to kind of regulate that, right? So, as we've seen, we had Twitter have a set of rules and principles, and those were now replaced by committees, user committees, etc. So I think the truth, or whose truth, is very difficult to judge, and so guardrails in those domains, are very difficult. I think in other societies it might be easier for them to enforce guardrails in the social sphere, right? I think where we can enforce guardrails is when AI is being applied to the physical domain, engineering, science. I think there the guardrails. Guardrails based on our engineering principles, guardrails based on models that we have built over the years might provide the guardrails that we need so that the AI doesn't hallucinate. I think engineers have a special relationship with language. And so having language models tell us how to build things and how to design things is a little bit of a challenge. So I think we need to bring the equations back in the picture somehow. So not just the data, but also the models that we have built over the years. I think them combined together will provide the right guardrails.
I appreciate that comment. I think this does require a different approach. We're not talking about an industrial revolution of the more familiar type. We're talking about a cognitive revolution. And I don't think we've ever dealt with that before.
Yeah.
And this requires some new approaches. And I don't think at this stage, I don't see them. And it worries me that we're going to strain the public trust if we don't do something significant. Thank you.
And Brian, I know I would expect you to respond on guardrails.
Well, I would say something to underlie that we should all be eyes wide open about is the mindset. And so, in my experience, I always like the Ernest Hemingway quote of "the world is generally a good place and worth fighting for," but he says generally.
Yeah.
Right? But with that piece in mind, if we always take into perspective two key things. One, in the human condition, there will always be people that do have bad actor intent.
Yeah.
So we should always be wide open and prepare for that. And then two is that we should never get so comfortable and complacent in accepting everything as 100% true and accurate. We need to have a mindset to, hey, this sounds really great, but test and evaluate and always be, one, postured for the bad things and bad people that may do stuff, but two, to always have not 100% trust in AI and that capability, use it as an augmentation piece. I don't know how many people know this, but like even the greatest of large language models right now, which is kind of a daily battle between Claude or OpenAI, still has a 7 to 10% hallucination rate, which is significant, right? I mean,
sure.
I don't know how many people used AI, this morning, but I did, and it gave me a little bit of a, okay, wait, well, let me double check that, So I think our mindset, we need to always have that kind of human trust but verify kind of mindset for, Will Reagan-esque.
Good. Thank you very much.
Thank you so much. And thank you for the plug for the bridge, by the way, NAE's publication. All right, over here.
Thank you very much. I have a question about what could we be doing? So this morning I asked ChatGPT, how much do we spend globally on education, innovation, career development, and so forth? And it came back with $10 trillion a year globally. And within the US, about $2.5 to $3 trillion a year. So my question, two questions. If we had $3 trillion a year to spend, and we had absolutely nothing, and we're going to build all of our new innovation and learning system over, what might it look like? What would we do? And then the other part of this question is, if we took 1% of that $3 trillion, or $30 billion a year, what would be the first things we could do with $30 trillion a year to get 100x leverage on the money we're currently spending?
Okay, there's some numbers thrown in there. I think let's open that up to, I think what I'm hearing, and correct me if I'm wrong, is if we have a clean slate to kind of go back to the beginning, what would you, knowing what you know now, invest in in terms of AI advancement? Is that correct?
We have no universities, no K through 12, no business, all
Very
open. And how would we design it today to get the most human value and most return on our investment for growth and human development?
Okay. I think it's going back to this age of abundance, which is, when we think about AI, it seems like there's like two sides of the coin, right? There can be this doom and gloom side, and there can be this happiness side. And I think you're asking about maybe illustrate some ways that AI can really lead to this age of abundance. How do we take this surplus to advance humanity? Any thoughts? Yes.
I can speculate a little bit on the way by which research will be conducted.
Okay.
I believe that the traditional way by which we do research in universities includes, a very specific model that includes the doctoral program. Students go in, they get educated, they do research. It takes probably 5 years or so to graduate. AI will accelerate the discovery, for sure. So the question is the future a doctoral program going to be 5 years, or it's going to be less? Is it something different? Would it be a very strong partnership with corporations versus the way it is now, in which is not practically, most of the time it's decoupled, and these are sort of separate. To me, I think that's probably the most disruptive thing that may happen in the future. We see it happening already because the federal money for support is going through some sort of a reconsideration in some way, let me put it this way. And so I think that may affect the way we carry academic research at the university. I don't expect the undergraduate programs to change because many times an undergraduate program is a place where students, so long time ago I asked the question in a naive way, what is a university? And some wise person told me it's a place where children, youth, grows from the age of 18 to 22 in a safe environment. That was the definition that I got. There is a way of becoming. There is an issue of learning many other things as well. This model has been around for a very long time. I'm not sure that AI is going to change it. Maybe it will expand it, augment it. I know of people like Peter Thiel says, don't go to universities, just go and start a company. This has been around for a long time, but hasn't happened. The majority of the students do that. So I don't expect this to be the case. Now, on the issue of the ROI that the question was asked, I can't really comment on that. I think it's a very important question. The question is, how do societies value the development of humans that are educated, they have critical thinking, and how is this to be created? And whether AI can provide or detract us from having actually a good critical thinking, because that will be actually the most important thing to keep having.
Great stuff. Yes, Mitch.
So we have talked a lot about that in the context of medical training, right? I mentioned that we're facing serious workforce issues. We also have medical training continue to lengthen. I made a comment at one of our leadership meetings that our MD PhDs, when they are getting their first real job, the friends they went to college with that went into finance are starting to retire. And that's a joke, but it's not as funny as you think it is. It really happens, And during medical training, we keep layering more and more on the students, and a lot of it is just information that they need to accumulate, vast amounts of information on various aspects of what we do. That information now is housed, is easily queried, and maybe we instead of teaching them to sort of put all that information in their head, more teach them a framework of how they can access and how they can use and how they can think about it to fundamentally change and to decrease length of training. And that's something that we're actively talking about. And I think there's probably corollaries in other fields.
Really interesting. I love hearing about the framework, but also increased importance of ethics classes, creativity, critical thinking, and how we can kind of reshift. So really, really great question. Thank you so much. We're going to go over here next.
Yeah, this has been a great discussion. My question, in a way, enlarges on what we've heard. One of the real challenges, especially with these neural nets, is they don't really have a good sense of humility. They don't know what they don't know.
Yeah.
There is some research that we're doing now to provide some uncertainty measures. But I think this is a real problem, especially in safety critical things like surgery and medicine, but broadly. So my question is, how can these new AI systems prioritize and convey the uncertainties? Right now, there is a technical problem of how do they internally recognize what they don't know. But then there's a second question in a human-AI partnership of how do you convey that information to engage the human. In your military analogy, you would have perhaps your intelligence officer would say, here, but there is the following thing we don't know. At least we would hope that was what happened. Could you all comment on that? Because I think this is a huge barrier for the deployment of these systems in any kind of, certainly safety critical application.
I think this is a great question. So it's kind of like, how do these tools give us transparency to their level of certainty or to a level of disclaimer so that it's not conveyed as kind of absolute truth? Who wants to take that on?
I would throw out first, I guess I'll jump into the deep end quick, that it's to the analogy of the double-edged sword of the humility. It is. So it goes both ways, right? So AI doesn't have humility, so at the same exact time, you can have it be critical of itself, right? And other pieces, what I do on a daily basis is I will pit large language models against each other. And so, years and years ago, it was in China, and I think it was Tencent that was doing it, but they created an algorithm that was a young machine learning methodology for creating false news stories. And then they created one that had, hey, identify false information in news stories. Yeah. And then they turned them against each other. Yeah. And they learned at such an alarming rate that they had to unplug it because it exceeded, they started, doing things in advance of, the human testing and evaluation standards. So they unplugged it. Yeah. But the same exact piece when I would say, hey, for inaccuracies and accuracies, if I go to ChatGPT, I don't use it as like a Google, I use it as a strategist and as a human interaction, and then come out with that answer. And now I use another large language model that says, hey, listen, now evaluate this and provide feedback. Is this accurate? And then if you continue to kind of look at it from that aspect, it doesn't have humility to identify that it's, it made an error. It actually would, and it's open, to be able to kind of, counter pit itself for some of the checks and assurance.
What you've described is the Section 5 people would call a GAN on steroids. Still, there is the question of how do you communicate the uncertainties. You're doing that now, but these systems, there is this other issue of you'd like the systems themselves to be able to evaluate themselves, but then communicate that. John Kennedy, it's tough. John Kennedy said that he wished he could ever meet a one-handed economist. But a simple recommendation on cut here is not something that we want in surgery. So,
I think let's pivot it to the medical field.
Could people? How do you communicate other than knowing to ask multiple of these systems?
But so at least in medicine, those kinds of systems are being built in where you've got adversarial networks that are and creating a high bar before the information is transmitted. So if it doesn't meet a certain level, it's said, I don't know.
Okay, that's the reliability, but still, do you
hold on,
want
let
to
him
communicate?
finish real quick.
Well, so as the recipient of that information, you'll get an I don't know.
Yeah, sort of.
No. You'll get an I don't know. You'll get I won't evaluate this particular, in our field of radiology as an example, they'll classify images into this one's positive, this one's negative, this one I don't know.
Anyone else? Sanjeev?
Yeah, so so we struggle with this all the time. So there's, two ways of looking at it. One is for the designer. How do you convey to the designer of AI whether or not his or her algorithm is working, right? So that, I don't know, and, those things. But that information that you convey to the designers is very different. That information is going to be completely useless to the end user because they have no way of dealing with that information, right? So we struggle with that a lot, and I think it's a very case-by-case basis on how the mission user uses the applications. That's one thing. And I think from a user perspective, we don't do this very often, but we should demand that the AI produces not just the result, but the uncertainties and the confidence with the results as well, right? We don't do that. We have, even when we do the APIs, we say, okay, give me the result and nothing but the result. And I think even if the AI is not confident, it comes across as very confident because, there is no way of conveying that, right? You're asking for something, you're going to get it, and if you interact with it a little bit more, maybe that's a different thing, right? So I think we need to demand that of the AI producers.
Great question. Thank you. We're going to go over here.
Hi, mostly for Mitchell. I have no experience as a doctor, an increasing amount of experience as a patient. And my question is, when and how does AI become part of the standard of care? How do you then adjudicate accountability for medical decisions in medical care? And then to what extent could then the patient be part of the accountability chain?
All great questions. Depending on what you mean by AI becoming part of the medical care, it is today. There are AI algorithms in equipment we buy. We are using in our EHR systems like ambient listening. Many of us have systems we create to go into charts and get information out for us that are AI based. What we're not doing on a routine basis is having it actually make those clinical decisions and having to make those clinical decisions with us. I think that's going to come relatively quickly. We're seeing things like, I'll give you an example, patients who come into the ED or their primary care office with a rash. Primary care docs, ED docs, they see some but not a ton of rashes. Their typical thing is send them to a dermatologist. Now you take a picture of the rash, you send it in, and you get back some ideas of what it could be, and you suggest that as a diagnosis. I think what there needs to be, and I've talked about this several times, is a framework for ensuring the quality of systems like that are helping you make those decisions or are making those decisions. And there is a precedent for this. And so when I was just starting in medicine, the laboratory pathologist who ran assays on your sodium value, your potassium, whatever, would go into the lab once in the afternoon with all of the aliquots of plasma that they've carried up with a bunch of technicians, and they ran a bunch of assays, and they, at that time, even wrote down by hand what the results are of all these assays, and then entered them into a computer. When automation came and made this much, much faster, there was still a responsibility for that laboratory pathologist to create that framework of quality to make sure that was an accurate number. And you still have a laboratory pathologist today that signs every lab value that comes out. That doesn't mean they did an assay. That doesn't mean they touched any of that sample. But it means that they ran a system, they did the testing that was required under a framework called CLIA, and they ensured that they got an accurate answer. And I think that's the framework we need in medicine. We need a framework, and think of this as an assay of information or of data, and think of the CLIA framework so that every time I ingest a system, I have a test process to test it in my environment to make sure it's giving the performance that's claimed. That every so often I retest it, that if I change anything on the input stream, I test it again and have a framework for testing. These are what we need to ensure these systems are accurate so we can work hand in hand, clinician, patient, and vendor in ensuring these systems provide.
Yeah, I appreciate that's the system on the, I'll say, automation or AI side, but what about the practitioner side, the medical doctor? To what extent is he obligated to exercise these facilities and this AI potential, as opposed to, you mentioned the difference between say, practitioner skill level. And if you go to, say, rural doctor versus a research lab, there can be quite a difference.
Yeah, I think that's going to, like everything else we do in medicine, we do studies to look at when we do interventions, when we change the standard of care, how much that impacts patient outcomes. And, if we get positive results, that will filter out, and there's some obligation of patients and, frankly, some liability if you don't practice the most modern medicine. So I think, we have to do trials that these systems actually improve care. Much the way we would do if it was a new drug, much the way we would do if it was a new procedure we were doing.
Thank you.
Okay, we're going to go over here.
So I first want to thank the panelists for really giving illuminating introduction and everything else. But it has raised one question in my mind. The question comes to the question of tools. AI is going to provide incredible tools to everybody. These tools in the hand of capable people will make them more capable. The corollary is that it will make incapable people appear more capable. and therein lies a danger, because there is a question about how do you put a human being in the loop to make sure that the outcome is right, but an incompetent person in the loop doesn't help anything at all. So what are some of the checks and balances that either as a society or the programming can provide to prevent such, I would not call it abuse, but less appropriate use of the tools that are going to be available? Because if all AI was going to do was to one AI program trying to find out what are the ills of another AI program, I'm quite happy with it, because the outcome is not really dangerous to anybody else. But when it deals with the human beings, society as a whole, we need to ask the right question. And maybe I'm not posing the question correctly, but I would like to hear more about how do you prevent misuse rather than abuse of the tools.
It's a great question. So I think the question is about misuse, but also how do we prevent a false sense of expertise? It's funny, when I was hearing you talk about a framework for medicine, I was also thinking about the framework of patients. I can only imagine there's a growing number of people that are diagnosing their own symptoms now and everything. And so just thinking about how these tools are used and how we can train the user as much as possible to be confident with their own inquiry skills and their own level of expertise and how they interact with these tools. So who's going to take that first? We'll go with Yanis.
I am on the end here. Well, clearly this is an issue of how the entities that want to recruit people to do that particular job, what kind of competence they require. I think that we will see a lot of universities, for example, generating or creating graduates on this AI plus something thing. The goal will be, not the goal, I think the ideal thing will be that these folks will be employed because they will have the ability to do exactly what we're describing and be able then to be used in the industry for that purpose. I do not know if the industry will be willing to go in that direction, though. And so there is a sort of a potential mismatch in that respect. I mean, we already see that, in computer science, graduates right now, sometimes they find not the same ability to be hired as before. And I think maybe that reflects a little bit of what you're describing here, that it's actually easier to hire people that are not necessarily as competent, but they can sort of be the sort of a proverbial human in the loop. And that, I think, is sort of consistent with what I was describing, that the domain knowledge has to continue existing in how we treat our students, and these folks should be able then to be supplying what is needed in the industry. Now, I know that, there is a lot of rhetoric about how, well, not rhetoric, but, the question is, can you train students in a different way that they traditionally train in order to go in that industry? For instance, from different places, not necessarily, R1 universities, but let's say community colleges or other things as well. And that is something that is also being shaped as well. I think it's going to come up at some point. It seems to me that, either this, I don't know if this can be regulated, or this will be the outcome of an accident that happens, and then obviously people will then get into a situation that they have to apply more stringent regulation of some sort.
Great. Any other, Brian, do you want to?
I don't know if I have a depth to answer the question you're talking to, but in my mind, what was just kind of, marinating a little bit is, we kind of already have that, right? So, the core tenet of artificial intelligence or technology or tools is to aid and assist, not supplant or replace judgment. And as we know, every human level of judgment, we have that, in society at large, people with really, really bad judgment to really, really good judgment. So it just becomes this magnification of, the human condition of making sure judgment is owned and operated by the human. Because no matter what we do, we're gonna have, in the words of a great sergeant major I worked with, sometimes there's just stupid people asking questions, not stupid questions. I hope that at the time he was not talking to me, but I think the relevance is, judgment has to be kind of a core fundamental tenet that we own as human in order to maintain our human agency over the technology and the tools that we implement.
Thank you.
Okay, we're going to go over here for our next question.
Okay, my question is actually directed to Professor Mitchell Schnell. Not only it's a healthcare question, it's also because my daughter is a UPenn graduate, and I promised her that each time I see University of Pennsylvania or Wharton, I will stand up to support. That's okay, so the question is, how much AI can reduce the cost of long-term care? And recently, I was convinced by my friend to buy a long-term care, and most of us, you can see here, we need that. This question is a healthcare question, but in the end, it's a financial question. With the help of Sanjeev and Brian, other panelists, give us a dollar amount. Currently, just for you, I was told that cost of long-term care is almost a full-time salary. Okay, so in the future, can we reduce that to like 20 grand a year, or that's my question.
Great question.
So I'll struggle putting a number on it, but I'll give you a number of the things that I think provide an opportunity to reduce long-term care. So there's a number of things. What you find in healthcare is that a big driver of care are patients when they end up in high-cost acute care settings. So emergency rooms, hospitals. When patients are in emergency rooms and hospitals, that drives the cost of care up. And so one of the things that you're starting to see, maybe in that first slide I showed where we're trying to predict patient outcome, we don't have large models, but people are building small models in, I'll call it, specialized contexts. So let's say congestive heart failure, which is a common cause of patients that end up in EDs and end up in hospitals. You want to predict those episodes before they happen, and then send people to the house to intervene, to try to prevent them from happening and reduce. And there's some evidence that you can reduce those exacerbations that send people into emergency rooms, that send people into, hospitals, and dramatically reduce healthcare costs that way. So there are a lot of strategies that are being set up. A lot focused, as I said, on reducing patients' need to come into acute care, high-cost settings, and keeping them out in the community that models can help us predict and help us offset.
Okay. Yesterday, I met my former colleague, Alfred Chow of Bear Labs, and he is 90. I'm not sure if he's here. He is come here with a personal assistant. Most of us cannot afford that. So I hope AI can do much better in the future. to reduce that cost. Okay.
Thank you for your comments and questions. I think it just illustrates long-term care, and there's like an infinite amount of applications that we're hoping AI can optimize, right? All right, go ahead over here.
Why don't we let him go first?
Oh,
because
okay.
he was here.
We will go over here. You have been given the microphone.
Okay. Thank you very much. Stuart Russell from UC Berkeley. So I want to pick up on an earlier question about the lack of regulation and do what engineers like to do, which is take limits. So the limit here obviously is the goal that the large AI companies are working towards of what they call AGI, artificial general intelligence, meaning systems that exceed human capabilities in every relevant dimension. And then the question is, and as Sanjeev mentioned, there's this potential risk of extinction. So as engineers,
doom and gloomer. I knew we'd get it.
As engineers, we like to quantify risks. And so if you're a nuclear engineer, you know that you have to deliver a nuclear power station design that has a risk of failure per year of between 1 in a million and 1 in 10 million. So if you then ask, well, why is that? Why do they have to deliver that level of reliability? It's because people are only willing to accept nuclear power stations in their backyard if they're that reliable. So what risk would the human race be comfortable with for extinction? Right? Again, let's be quantitative about this, right? It's got to be a smaller risk, right? It's got to be a smaller risk than the risk that we accept for nuclear power station meltdown, because it's a lot worse, right? So maybe it's 1 in a billion per year, or maybe it's 1 in 10 billion, but it's a very small number. Now, if you ask the CEOs of the companies who are building or trying to build AGI, what risk do they think their technology imposes on humanity? The answer you get is somewhere between 10 and 30%. So if the human race says, well, no, the risk that we are willing to tolerate has nothing to do with the reliability that you can deliver, right? We are facing basically a collision where the human race says we are willing to tolerate 1 in a billion or 1 in 10 billion, and the companies say, well, we can only deliver 1 in 10. And should the human race accept that the companies, because they can only deliver 1 in 10, should just go ahead?
I think what sounds like a very existential question. It's also a policy question, right? And how do we determine what level of risk is acceptable for society and a lot of these models? And Sanjeev, he put you in the hot seat, so I'm putting you in the hot seat first.
Okay. So I did some work for a chemical company in terms of risk, and the acceptable risk that they accepted was, okay, it should not add to the risk that you're exposed to in your normal daily activities, by more than 1%, right? So 1% of your risk of death because of other things, right? And so I think a similar kind of framework needs to be thought about AI as well. But I think the risks that we accept are also very activity dependent, right? So I think, so nuclear, rightfully or wrongfully, has a very high barrier. But we routinely take risks in our daily lives, skydiving and things like that, which are Is
that your daily life?
Not mine.
But I think that's an interesting example, because we don't drop everybody out of planes without asking their permission.
Right. Exactly. So yeah, I think we need to have a serious discussion about that. And 25% extinction risk. I think those are just numbers that we are making up. I don't think we have any real numbers, to think about what is the risk of extinction. So it's a discussion we need to have as a society. And I think that is the problem that you're pointing out. We are not having those discussions, in earnestness, right? So I think that is the challenge that we need to face, and that is what we need to, address is, can we have serious discussions, not, the doom and gloom type and everything is great type, but, what is a good way of dealing with those, the risk discussions, and can we have a scientific discussion around those risks?
Brian, I'm going to go to you next. Oh, I was going to do Brian next. Brian,
okay.
Yep.
So I would play a little devil's advocate with you in coming to a quantifiable value for what that risk and the existential piece may be, pushing us towards analysis paralysis. So, because I think it's going to be a value greater than zero, right? So there's something there. And when it comes to the existential threat, I did this with my daughter. Sorry for a little segue, but she loves astronomy. She loves her Big Harrow picture of forming universes. I introduced an agent from ChatGPT that's the children's astronomer into our conversations when we talk about it. And one day it started going down, and she asked about the different colors in the stars, about what is a red mass, and how our sun is eventually going to be this hot death for the Earth. And I'm like, oh, okay, all right, we're done with this. Let's move on. So the risk piece is really the core fundamental piece that I would turn back to, in that in special operations, in a lot of different things that we do across all these different industries, for SEALs, as much as we say as great as we are, we're actually really, they don't do these impossible tasks all the time because we're just so great. We do it because we have unbelievable systems of operational risk management. And so all of these different methods that we put into place to ensure that we adapt to the environment, to make sure that it is never a fair fight in any way, shape, or form. That is how we maintain advantage. So I would kind of throw it back of like, hey, if we spend time trying to figure out a value for humanity at large of what is acceptable for our existential kind of decision point with AGI or whatever it may be, all these different countries, different people, different societies are going to have different values, versus I think we should start preparing and building your risk mitigation measures to try and adapt to some of those things. To be, does that mean go into a bunker in the middle of the mountains or something? But how you look at it has to be an individual kind of pathway. But look at the mitigation pathways versus the valuation of what that risk is acceptable, because it's going to be different for my 8-year-old versus my 3-year-old son. So there'll be different values that you want to take a look at.
But I don't think anyone thinks we would accept a bigger risk of extinction than we accept of a nuclear meltdown. So let's say we say, all right, 1 in a million years. Companies, you want to do that? Prove to us that your risk is less than 1 in a million per year. And they can't do that. That's the problem we face.
Yanis, I know you're interested.
This question reminds me of the Yucca Mountain project for nuclear waste disposal, because I was involved in that conversation back in the 90s. Not the conversation, but in the committee that assessed the validity of that. The Nuclear Regulatory Commission, the NRC, requested that if you were to sort of bury, if you wish, the high-level nuclear waste that was military level inside the Yucca Mountain in Nevada, that 10,000 years from now, if a peasant 10 kilometers south of the mountain drills a well, the radioactivity in the water there will not exceed a certain amount of thing. So in a way, it echoes what you're trying to say, of course for a different type of problem, and that there the unknowns were precipitation in the mountains, how the water penetrates the mountain and corrodes the canister, then releases radioactivity, and so on and so forth. What I'm trying to say is that, by the way, that particular project was deemed feasible, even though one had to make a 10,000-year prediction, which was kind of a fraught with uncertainties, but nonetheless ended up not being used for the disposal of nuclear waste because of political reasons. There was a very important senator in Nevada who says, over my dead body, this is not going to happen. And he had nothing to do with science, but it was a political thing. But to me, brings up a point that the scrutiny of doing something of this type, which was less existential, was much more scrutinized than what actually we're doing today. And I think, to me, it's kind of an interesting thing in very stark difference between the approach that was taken then versus what we do now, which I think I kind of agree with you that we have to be a lot more circumspect about the direction that we're going.
Thank you. Thank you for your question. Okay, we're going to go over here for our next question.
Yes. Thank you for the very interesting discussions from the panelists. I have a viewpoint, which is that I also study quantum technologies. The world is inherently random. So, but this thing has not been built into your AI predictions. So I think if together with your AI prediction, you put in confidence level, standard deviation, and so on, especially for medicine, for Misha's work, I think it will make us a lot more confident with AI prediction, because you get a number and answer for ChatGPT, but there's no any analysis of the certainty of the prediction. I think we can improve AI by putting error bars. Like I used to work with experiments. I'm a theorist, and says your calculations is no error, but they're not very useful. But to experimentalists, error bars are very important. This is my 2 cents worth.
I think I think to pivot that into a question, maybe you can just elaborate on. There's a lot of talk about ChatGPT not giving you any level of certainty, but I know you've talked in the medical field that you are getting advice, you are getting I don't knows and things like that. So maybe just make the distinction a little bit here.
Well, I mean, one of the from the medical perspective, one of the concerns that we have about things like ChatGPT and how much it's democratized information about healthcare is that it is completely unregulated. And so there's no sense of accountability for the advice it gives. And it sometimes gives very good advice. And to your point, hallucinates a fair percentage of the time, and sometimes gives bad advice with bad outcomes with no accountability. In medical provider space, right, we have accountability for providing, good care, and we demand that we have, some level of certainty or some humility, if you will, of the AI systems, or we're not going to be able to use them. And so I completely share your suggestion that, having information about uncertainty, certainly in our world, and I suspect many worlds, is absolutely crucial.
I am glad to hear that you have one of your answers been, I don't know. I think that's a great answer, because we shouldn't improve confidence level of the doctor by studying the data.
Right, and put a high bar for when it knows. Make sure that's a high bar.
Yeah, thank you.
Great, thank you. All right, we have about 10 more minutes, and we're going to go here for our next question.
So, Mitch, if I heard you correctly earlier, I think you're thinking about something which I think is extremely important. And Dean, I know you're thinking about it. So if we look at the development of a competent practitioner, whether it's a medical doctor or an engineer, there's the educational experience, but even for the practicing engineer, it's at least 10 years of outworking, the experience. So that's the time frame. And what I heard you, Mitch, you talked about how they would just add on more knowledge and knowledge and knowledge. Knowledge is becoming a commodity, right? So I would posit that what will differentiate the competent practitioner is not what they know, because they can get access to that. So it'll be something different. It'll be some totally different things. So what what should we be thinking, we collectively be thinking about taking out of what we're trying to cram into people, and what should we be adding? I think it's less knowledge and fundamental understanding and skills, just to tell you what I'm thinking, but I know the two of you are thinking about this. I think this is extremely important.
So I come from a physics background, and in physics, the most important thing you need to be able to do is you need to know how to ask the right question, right? And, you know, physicists always think they're the best at asking the right question. And so to me, that's the differentiator.
So it's helping much more consciously, spending more time and working much more consciously to help people develop. I mean, everybody has a certain native skill, but you know, the way you develop skill is you practice, right? You practice.
Yeah, how to pose the question, though, I think is really critical.
And Yanis, I think this is an education piece too, which is if information becomes a commodity, how does it change the face of how we train our future engineers to interface with this information, right?
Yes and no. I mean, information as a commodity, the question is how does information, how science advances? How do we get things that are new and develop? I think we're in the business of doing this as well. And it's not simply in the business of simply packaging information and giving it to people. I think we will be doing the wrong thing by doing this, even at the undergraduate level. I think we need to tell people that this is something that is evolving and changing and becoming important. And you know, something that we have not discussed a lot is explainable AI. I very much believe that explainable AI is something that's very important for us to understand what exactly AI. That's what I was saying, that we need to understand how AI works, all the the nitty-gritty. I mean, I had at the beginning when I learned about ChatGPT and all that, I tried to make the following analogy. You know, before Newton, we did not understand nature, nothing. We did not understand, we didn't have tools, we didn't have differential equations, we didn't have calculus. We were completely, ignorant, and then we worshipped all kinds of different things. The ancient Greeks, since I'm talking about Greece, they worship the god of wind and things like that. Okay. Now, of course, with calculus, we understand a lot more things. My question is, can we get insights from the way AI responds that will help us develop maybe some new language in which we can interpret nature, complexity, all of these other things in a way that we don't know this way? But maybe some very sharp person out there will come in and say, just like Newton, hit the apple, hit him in his head and figure out how to do these things. Maybe we'll figure out something similar to that.
Thank you.
Okay, we're going to go here. We've got maybe time for one, maybe two more questions, depending. We'll see.
Well, thank you again.
Yes.
Excellent conversation. I have one question and one comment. I'm AJ Malshi from Purdue. That every time I hear the word human in loop, and that is being used quite oftenly, are we talking about one human, a colony of human, or the earth? Because that, in my mind, is the biggest problem here. I mean, how many humans can trust other humans? How many humans can trust the government? I mean, we have absolutely interfaces of distrust between individuals, communities, societies, and the nation. And now on the top of that, you're overlaying the AI, and there are different types of AI. Means we are putting the problem of distrust at scale. And that's how I see that we are building a system that we want to be certain, we want to be trusted AI, but we are building a system for an extreme high level of distrust. And we are going to need an AI, super AI, just to do that. I mean, does that make sense?
So I think the question is about going back to humans in the loop. Is there an expectation that there's one, multiple? How do we create a level of trust? Is there a whole new field of expertise where you're a trained human in the looper that's trusted?
Most people call super intelligence. I call it super distrust.
So I think that's at me. So I think that to the human in the loop piece, it's more, I guess, the euphemism for human agency into the technology, and it's the accountability factor in my mind, and training humans in the loop. I think it's better put as the analogy of, as humans use tools and technologies, it doesn't dismiss them from the accountability factor of what comes and what results from that. So when you look at like the levels, and we had a great question earlier about, hey, at low level, in between, how do we find the air gaps, all those different things. Those are methods and tactics and procedures and technologies that we develop and need to develop and keep working and currently have to improve. But at the end of the day, I think my key relevant point that I come back to, and what has brought me on this journey, is at the end of the day, I can be faster, smarter, better, and do more things, with the aid of this capability. But I can't dismiss the fact that that I have to own whatever judgment comes from that. Because I'll be perfectly honest with you, there is no chance that I would be up here on this stage able to talk about any of this stuff in 2018. Because the only way I got here was by learning, adapting, and I'm still at the same exact point that I was in 2018, which is I own the outcome of what I just decided. So that's the way I would translate. I don't know if that answered your question, but that was.
I think we're actually gonna wrap up, but I think that's a really great place to end on, which is owning this outcome, right? I think we've talked a lot about humans in the loop. We've talked a lot about building a framework, and I think this is a call to action across all sectors, across all sections of the NAE, across all aspects of livelihood. That we need to all be involved. We need to be invested in this process, and we need to act fast in the process of making this framework. And so I want to thank everyone in the audience for all of your insightful and engaging questions in our forum about the future of AI, the risks and opportunities. Of course, I want to give a huge thank you to our panelists, Sanjeev, Mitch, Brian, and I know Yanis, our plenary speaker. Please join me in giving a round of applause.